So first thing we're asked to do here is find the inverse of this function. Now I was kind of shocked by how many people on the quiz still did not know how to find an inverse function. Considering it was a partner quiz, you would think 1 out of 2 people, at least one of you would know how to find the inverse function. How do we find an inverse function? What do we do first? You flip the x and the y, right? So we have an x out front equal, oh, that's way too big, equals 2 square root, and instead of an x inside, it's now y minus 2. Then what do I do for, oh, so thank you so much, plus 3. Then what do I do first? Yes, I need to get the 3 over to the other side. Mm-hmm. Then what? Divide by 2. And how do I get rid of our radical here? You square both sides.
Oh yeah.
Do you actually need to square this term? No. If we were being asked to solve for x, yes, we would have to square it. But are we being asked to solve here?
No.
No, we're just being asked to find the inverse. So you can leave it like this. Then what? Then you need to add 2. Now my original function was f of x. So what should I write here? F negative 1x, or the inverse of f of x. F inverse. This is our inverse function. Most people got this. Most people got this correct. Now, what threw you guys for a loop was the restricted domain part, right? At its bare bones, all that a restricted domain means is it's a limited domain. It is a smaller amount of numbers than the original domain. The reason why on this problem it's called a restricted domain is because if we're looking at a graph of this, a little tiny graph, and I graph my original function, which, where is the starting point on my original function?
2.
It's at 2, 3, right? So I'm going to graph that, 2, 3, right there, and it hasn't been reflected, it's just been stretched by 2, so it's like this. Okay? Now, that original starting point is 2, 3. Where is the inverse function starting point going to be? At 3, 2. Right here. And remember, we're always reflecting over this line, y equals x. So my graph is going to look like this. Is it a full quadratic? No. However, if you look at our inverse function, is this a quadratic? Yes, it is, right? We have an x that is eventually what? Squared. So is this a quadratic? Yes. However, are we wanting the full quadratic? We're only wanting how much of it? Half. The domain is being restricted. What is the domain being restricted to? What is the x value for our pink inverse line? So we want all the x values that are bigger than 3. Greater than or equal to 3. So that is our domain. Everything bigger than or equal to 3. Because this point right here is 3, 2. This point was 2, 3. Yeah, exactly. We have dealt with restricted domain before, but the problem was totally different. The problem before with restricted domain said, find the inverse function and then restrict the original's domain so that the inverse is a function, right? We do that type of problem when instead of starting with a radical, we start with a quadratic. Because remember, I'm graphing a quadratic. The inverse of this, is that a function? So I would need to restrict the original's domain so that the inverse created is a function. So there are two different types of applications for a restricted domain in this unit. Does that make sense? Are there any questions? Yes. Of which one? Of our warm-up? So normally the entire domain of our quadratic is what? What is normally the domain? If this were to continue, if instead of finding inverse, I just first looked at this quadratic. Oh, let me redraw the. So I have 1, 2, 3, 1, 2, 3. My vertex is at 3, 2. If instead of having just the inverse of the radical, I had the entire quadratic, what is that quadratic's domain? All real numbers. So we're going from all real numbers to just the values that are bigger than 3. This is the restriction. We're restricting it from all real numbers, which is what this quadratic really has, to everything bigger than 3 because we only want half of the quadratic, actually. Yes?
How do you know how to, like, which way to draw your line?
I just remember that a normal, not reflected radical goes like that. You just have to memorize that.
If it's reflected vertically,
If it's reflected vertically, what does it look like?
down. And then horizontally.
Horizontally, from our original, would be like that. If it's both vertically and horizontally reflected, it'd be that. Does that make sense? So let me draw it all on one graph. Let me draw a bigger graph here. What is going on?
Do it like if it's a stretch or compression.
Yes?
I don't understand.
So if we have a graph, and this green is my normal, it's my original. This is vertically reflected. This is horizontally reflected, and this is horizontally and vertically reflected. This is the original.
That's helpful.
Okay, yeah.
Is it?
That actually, yeah.
Yes, that's so
I get that. Yeah.
If there's like a stretch.
It just gets like skinnier or wider. So if the original had been stretched, it would be taller, vertically stretched. If it had been compressed, it would be wider. So this is vertically stretched. Oof. And this is vertically compressed.